Got a cell phone in there, who knows? The topic of today is, or of this talk anyway, is securing the client side. It's kind of, I think, an interesting topic for a Java conference because most Java programs have very little to do with actually building HTML and pushing it out to clients. It is, however, the case that if you want the largest market possible, the target of your language, or whatever your application is going to be JavaScript, it's going to be CSS, and it's going to be HTML. That gives you the ability to push your application out to a huge audience that you simply wouldn't have access to if you try to deploy something in a more native way. The web is simply the largest platform out there. And a consequence of this is that we're slowly seeing more and more of the application logic being moved down to the client side. It's moving out of these large back-end systems and moving down into JavaScript and executing then on a client's computer, on an untrusted machine, as opposed to a machine, the server, that you have complete control over. There are a couple of things that you can do on the server side in order to ensure that your application is secure, to ensure that no one can write things into your application that you don't want, and to ensure that the code that your application delivers is secure when it actually gets to the client. We're not going to talk about that today. Instead, we're going to focus very specifically on what you can do in the browser in order to ensure some measure of security for your application. It's simply the case that the browser is an untrusted environment, so you need to be very careful about what you're doing. But at the same time, there are some new capabilities coming out in browsers of today that allow you to ensure that your application is delivered in a way that maintains some degree of security. The web is simply a scary place. Has any of you seen a screen like this in Chrome or any other browser? Most browsers today have some sort of safe browsing system, which tells you when you're visiting a site that we know could be problematic. So if we've seen a lot of malware on a site, we have mechanisms by which we can inform the browser that a specific website might be problematic. It's most often the case, however, that the things that we're really worried about aren't pervasive and aren't persistent on a website. It's very difficult for someone like Google or Mozilla to detect malware on a site if the site itself is benign. There are a variety of attacks that can allow someone to inject code or inject content into a website that's otherwise perfectly benign and only affects the person who is actually visiting that page at the moment. It's called a cross-site scripting attack, and there are a wide variety of mechanisms that allow it to occur. I'm going to talk about two things that you can do to reduce the capabilities of someone who would be attacking your site and to mitigate the effects of any attack that did get past your defenses. But before I start talking about things that you can do to defend, I want to talk about one thing that I see as an absolute prerequisite for any discussion of security on the web. You must send data and accept data over a secure channel. There's really no excuse these days for using HTTP as opposed to HTTPS to deliver an application. Applications must be delivered over HTTPS because that's the only mechanism by which you can ensure that there's even a modicum of a chance that the data that you send out and the data that the user receives are identical. Our view of the web kind of looks like this. We think about it, I have a laptop, I go out directly to a server, I pull some information down, I do something locally, and then I send more information up to the server. We think about these direct connections. But of course it's the case that there is no direct connection between me and a server. Instead, I go to a coffee shop. And in that coffee shop, I hook up to their Wi-Fi network. And then, in order to transmit my requests up to the server, it hops and hops and hops through a variety of routers and a variety of different servers until it actually hits the endpoint that I care about. That's a lot of things that I have to trust. It's a lot of different servers that I need to ensure that if I want to ensure that the information gets from A to B intact, I need to trust each of those points in between. If you're sending information over HTTP, it's very likely that something like this could happen. It's called a man-in-the-middle attack. I send information over HTTP. Some malicious server in between me and the endpoint takes that information, modifies it in some way, and then sends it on, acting as a proxy between me and the server that I actually care about. At this point, it's pretty much game over. If I'm sending information over an unencrypted channel, that man in the middle can take the information, either read it, modify it, do really whatever they want. And there's no way to detect this sort of thing, because HTTP has no sort of encryption associated with it and no sort of signature associated with it, which means that the information that I receive, I simply have to blindly trust that it's the information the server actually sent down to me. That's something that I don't think anyone should be doing when writing an application. When writing an application, you should instead be very certain that you're sending information over HTTPS. HTTPS gives you a mechanism by which you can first encrypt the connection between you and the server. It still hops over a wide variety of routers in between you and the server, but none of those routers have the ability to read the information because they don't have the private key that exists on the server. At that point, you have some measure of security, some measure of privacy, that is, in that the information can't be read. Second, you have a measure of security in that the information can't be modified as it's sent back down to you without re-encrypting the information using the same key as the server. This is very difficult to do. It's not impossible. So this isn't a completely secure solution, but it's miles better than HTTP, where you have absolutely no guarantees whatsoever. Anyone who's running a server should still listen on HTTP ports, because most people will just type in the server name into the browser, and the browser will default to HTTP. It'll go out to the website, and then something like this should happen. You should be doing a redirect. It's kind of cut off on the side, which is annoying. What you see at the top is a curl ahead request to mkw.st. It's going over HTTP, and at the bottom you see a location header, which redirects me to the HTTPS server. This is good. This means that most of my connections will be over HTTPS, but it leaves a vulnerability because that first connection is going out over HTTP. It'd be nice if we could somehow inform the browser that it should default to HTTPS as opposed to defaulting to HTTP. As it turns out, we can. There's a new header called strict transport security. Strict transport security says, I'm sending this information over HTTPS, and next time you connect to the server, forget about HTTP. Even if the user types in http://server name, go over HTTPS. Do the redirection client side, as opposed to making a request and letting it happen server side. There's a max age associated with this, so you can say for a month, do this sort of thing, or for a year, or for however long you actually trust that you'll keep your certificates up to date. And there's a mechanism by which you can also say that all subdomains of this domain should also be protected by strict transport security. This is really good for you guys to be doing. So I would very much recommend that anyone who's writing an application that's delivered over the web, go to StartSSLcom or any of a number of other certificate delivery websites where you can sign up, get a certificate, associate it with your website, and ensure that your application is being delivered in a secure fashion. Once you've done that, go ahead and set up strict transport security headers on your website so that you ensure that your users are always visiting your site over HTTPS. It's really almost a no-brainer. StartSSL in particular is great for people with really small applications. It's also good for large applications, but for people that don't need these warranties that are associated with the larger certificate manufacturers, StartSSL is absolutely free. They only charge you for the work that they do. So if you don't care about authentication, or not authentication, if you don't care about verification, then you can get a free certificate for your app that works in all browsers, which is great. If you do care about verification, or you want wildcard certificates or something along those lines, the level 2 verification is like $60, $60 US for 2 years, and you get unlimited certificates associated with that. Given this sort of thing, there's really no excuse to not have certificates, even for the smallest of projects. With that out of the way, with that as a basis upon which we can build everything else, let's talk about the sorts of attacks that I would like to help you defend against. The most common is a script injection. So if we go to google.com over HTTPS, of course, we might see something like this, an alert box popping up that says XSS. This is kind of the very typical thing that if you pay a penetration tester to go out to your website and show you the vulnerabilities, this is most likely what you'll see. You'll see, I was able to inject script into your site, and that script executed and popped up an alert box. It isn't very scary though, right? It's just an alert box, so why should we really even care about it? What's more interesting, of course, is to pop up the user's cookies and show them that by executing script on their site, you have access to all of the information associated with that origin. The web is generally protected by the same origin policy. That is, a website consists, or the origin of a website consists of a scheme, a host, and a port. That is HTTPS google.com 443. It's simply the case that that website should never have access to information on a separate origin. So Google should never have access to my bank's information, for instance. This, of course, is the downside of beards. Beards are generally excellent. I highly recommend them, but if you have a microphone on your face, it makes it slightly difficult. Regardless, document.cookie can be read by any JavaScript that's associated with a particular domain or a particular origin. Generally, things are protected by the same origin policy. That is, Google can't directly access anything from my bank. But if I'm able to inject malicious JavaScript into the context of google.com or any other website, the browser has no mechanism of distinguishing between a maliciously injected piece of content and a piece of content that was injected intentionally by the browser or by the author of the site. So we see two alert boxes here. And if we actually saw this when an attack was going on, there would be some measure of protection going on. But usually what we see is absolutely nothing. We visit a site, it looks just like any normal site, we interact with it, and transparently in the background, the person who's attacking the site is either exfiltrating sensitive information, pushing out my cookies to a third-party server in order to steal my session, or a wide variety of other things. Generally speaking, if someone is able to execute JavaScript on your site, it's more or less game over. They have complete control over the site, and they have complete control over the information associated with that site, which is pretty problematic. This is a really excellent website to go to if you're interested in how a cross-site scripting attack might look. It's called the XSS Cheat Sheet, and it's delivered by OWASP, which is a security, an organization of people who are interested in security and put together a lot of documentation, a lot of trainings along these lines. It's a really long document because there are an incredible amount of ways of injecting code into a site that doesn't properly escape its output. JavaScript is really interesting in that it accepts a wide variety of syntax, and it's very difficult to ensure that you've escaped everything correctly such that JavaScript doesn't execute if you simply echo any information that's been delivered by a user, or any user-generated content in general. There are two things that you need to do in order to protect against cross-site scripting attacks. And if you do these two things perfectly, you are 100% guaranteed that you will never have a cross-site scripting attack on your site. First, you need to validate all the information that comes into your website. So if there's a form where you accept someone's phone number, you want to ensure that you only accept phone numbers, that you don't accidentally accept JavaScript. One mechanism might be stripping out everything that isn't a number, right? Then you're more or less guaranteed that you have something that you can safely put into your database and that you can safely deal with on the back end. The next thing you want to do is ensure that you correctly escape every piece of output that you write to a site. So if you have any content that comes from a user or any sort of untrusted source, then you want to ensure that you escape that output correctly when you write it out to the screen. I said you need to do it perfectly, and unfortunately, escaping output is much more complex than it seems. Here we have a little bit of HTML, and what you notice here is that there are 5 different contexts in which information could be output. This is a more or less exhaustive list. You have style information, you have raw HTML that's inside the p tag, you have a URL that's inside of an attribute, you have information that's being written out directly into script. Never, ever do this, right? Never write information into script. That's just a bad idea. And then you have information that's written into a comment on a site. You usually see this as debug information, where people just write out information so that they can figure out what's going on their own site. Unfortunately, each of these contexts has different escaping rules. And you need to be very sure that you're escaping content correctly for the context in which you find yourself. Again, if you go to that website I pointed to earlier, it gives you some information about these contexts and about what the rules might be. For instance, inside of an attribute, you need to be very sure that you correctly escape quotes. And it's also the case that quotes aren't actually necessary. So you want to make sure that you escape the content in such a way that it's interpreted as an HTML attribute, as opposed to potentially as script. Fortunately, this is a completely solved problem. It's been solved at least since 2009 when Google released an automatic context-aware escaper. There are escaping mechanisms in basically every toolkit that people use nowadays. So if you use Rails or Django or whatever Java people use, then there are, I guarantee you, mechanisms by which you can escape the content, in which you can guarantee that the content is being escaped correctly when it's delivered. As I said, however, you have to be absolutely perfect about the way you do this. You have to ensure that you perfectly escape every piece of output that goes to the site. Unfortunately, it's the case that attackers will spend much more time trying to find a single tiny hole in your application than you will spend defending your application to maintain the status quo. You're going to be busy building new features. You're not going to be very busy looking at every piece of HTML that you ever generate and ensuring that the escaping that you do is correct for the individual context. empirically, we see that people make mistakes. It's simply the case. And it's not even the case that you have to make a mistake. A browser vendor might make a mistake as well. If you look at old versions of IE, it's very much the case that strange things need to be done in order to ensure that content isn't executed as script. There are simply bugs in the way that browsers parse things. It's a losing battle, in other words, to ensure that every piece of content is correctly escaped for every browser that a user might come to your site with. It's something that's very, very difficult to do. So we make mistakes, browser vendors make mistakes. It'd be really nice if we could simply instruct a browser in some way that this piece of code is valid and this piece of code is invalid. I mean for you to execute this piece of code, but this other thing over here, why don't you leave it alone for a little while? This boils down, I think, to the principle of least privilege. The idea is that every application, or every piece of an application, should have the minimum level of privilege necessary in order to do its job correctly. This is really quite common in the Unix world, where you see a process start as root, set things up, and then immediately fork and drop down with set GUID in order to have fewer privileges, in order to ensure that it doesn't have access to things that it shouldn't have access to. This is why you usually end up with like a MySQL or a PHP user on a variety of systems. Those users have fewer privileges than root, and the system makes sure that the application runs as that user as opposed to a user with higher privileges. The good thing here is that if you minimize the privilege that an application has, then when an attacker finds a hole, and it will be a when, not an if, then the attacker has a reduced surface area with which to work. They don't have the ability to, for instance, write directly to the disk. And in that case, you've protected yourself simply by minimizing the value of this application as a target. Has anyone read JavaScript: The Good Parts by Douglas Crockford? That's a good number of you. I think this actually fits very well into the concept of least privilege. JavaScript: The Good Parts has basically the single theorem that there is a beautiful language hidden inside of JavaScript. The JavaScript itself is kind of large and has become ugly in a variety of ways, but there is a beautiful core. And if you limit yourself to this core, if you restrict yourself from using some of the more esoteric features, then you have a much easier language to understand, but also an easier language to program in and to reason about. My contention is that you can do the exact same thing for HTML, and that you can do the exact same thing for your applications. You can explain to the browser that certain things, even though you would be allowed to do them, shouldn't be allowed within the context of this individual site. The way that you do this is via content security policy. Content security policy was originally invented by Mozilla about 3-4 years ago. It was implemented in Mozilla, I believe, Firefox 4, and has been slowly improved and steadily improved since then. It's now in the W3C on standards track. I believe actually today it will move from working draft to candidate resolution, which is the next step would be proposed resolution, and at that point everyone should implement it. Content security policy gives you exactly this mechanism. It allows you to very clearly explain to the browser which things on the page, which pieces of content are intentional, and which pieces of content should never be executed. It allows you then to, well, let's look at MikeWest.org. So MikeWest.org is my website. And it has a variety of pieces of content. It has images, and it uses some web fonts, it uses some script and some style. And we can very clearly explain to the browser that certain pieces of information or certain sources of information are trusted. And any other source, if someone was able to inject content into my website, because it is, of course, incredibly high value, then you would be able to very clearly distinguish between the injected information and the intentional information. The policy is an HTTP header. It can also be injected as a meta tag in Chrome. And it looks something like this. Content security policy is the name of the header. And then we walk through a variety of directives. And each of these directives allows you to very granularly control the information that is delivered to a website or that the browser should interpret as part of the website. We start out by making it secure by default. So we set a default source of none. This means if we left it at that no content would run on the site whatsoever. It would render HTML, so the things that are contained within the website itself, but no images would load, no script would execute, no style would load, no web fonts, no media, no XHR. Basically, it turns off anything that could inject content into the page. Then we slowly loosen this policy by saying, for instance, that mikewest.org.hasacdn.net is a valid source of style. So I can load a style sheet from this origin. And if it comes from this origin, then the browser will allow it. If a style sheet comes from a different origin and is somehow injected into the page, the browser will simply not execute it, will not render that information. We can skip down to script source, which does the same thing. It says mikewest.org.hasacdn.net and ssl.googleanalytics.com are both valid sources of script. If I load script from these origins, they're trusted. If I load it from any other origin, it's untrusted. So if someone was able to inject a script tag into my site, they would need to ensure that their malicious script existed on one of these two servers, which would be a very difficult problem indeed. This is a more or less complete list of all of the directives that are available in Content Security Policy 1.0. Content Security Policy 1.0 is going to, as I said, to the next step in the standards track today. It's implemented in Firefox, it's implemented in Chrome, it's implemented in Safari 6, and IE 10 it implements a single directive. So they're working on it. They're not quite there yet. Opera is participating very heavily in the standards process, so we expect that Opera probably 13 will have something like this. But at the moment, it's across about half the browsers that you'll see on the web. So default source, we talked about. Script source. Object source allows you to control plugins that exist on the site. So you could say, flash files only from this. Style, images, media allows you to control HTML5 video. So if I'm loading video information or subtitles or something along those lines, that's controlled via the media source. Frame source allows me to determine which items I can load into frames in a website. So I might say that I only want to load YouTube videos. So I would allow https youtube.com as a valid frame source, and no other frame would then render on my page. This gives you the ability to then very granularly determine which pieces of information should be part of your site and which pieces of content or which sources of content should never be allowed access to your website. It has a downside, however. Well, not really a downside. I think it's an upside, but a lot of people see it as a downside, so I talk about it that way. The main vulnerability that we see in cross-site scripting attacks is inline JavaScript. That is, I request a page in such a way that causes it to write out a script tag or to write information into a context that gets executed as script. Content security policy takes more or less a take off and nuke it from orbit approach to inline script. That is, it bans it completely. This is actually, I think, a good thing. It enforces the strict separation of content, behavior, and rendering that we see in HTML, JavaScript, and CSS. We've been talking about this for years as best practice, that you should separate your page out into an HTML page that has clean markup, a JavaScript file that enhances the behavior of the page in some way, and then a script or a CSS file that enhances the rendering and makes it look pretty. What we see here is an inline script tag that defines some functionality. We see an inline event handler that associates that functionality with a click on a button. And then we see a JavaScript URL that's in a link that associates, again, this functionality that we've defined with a click on a link. All of these can be trivially rewritten by extracting the JavaScript out into a separate JavaScript file, loading that JavaScript file in my HTML, and associating the handlers of the events via JavaScript as opposed to doing it within the context of the markup. This, I think, is a good thing regardless of whether you use content security policy. Again, it gives you this clean separation between your markup and your behavior and allows you to edit each independently. It gives you a very clear picture of where your behavior is happening and where your markup is happening. And it gives us the ability to very clearly distinguish between code that's been maliciously injected into your site and code that exists on a trusted source of information. That is, if I have an external JavaScript file, the browser can very clearly determine what the origin of that file is. If, on the other hand, I have an inline script, it's simply impossible for the browser to make a distinction between inline JavaScript that's been maliciously injected and inline JavaScript that you intended to have on your page. So again, content security policy allows you to reduce the privilege of your website in a way that protects you from this sort of attack. It allows you to say that I'm not using inline JavaScript on my site, and I don't want inline JavaScript to ever execute. This gives you the ability to instruct the browser to help you out. The browser can then be your friend. It can help you ensure that only the information that you've actually delivered is getting executed in the context of the website. What's also interesting about content security policy is a reporting function. It's almost never the case that you can cleanly deploy a new content security policy onto an existing application without breaking something. Content security policy gives you a mechanism of doing first a reporting mode, where you say, okay, I want to try this policy out on my application. And you can deploy this to actual users. If you use content security policy report only, then the policy will be evaluated by the browser and will be interpreted, or each load of a resource will be interpreted against the policy or validated against the policy. If it passes, great. If it doesn't pass, the load will go through, but it will send a post out to an endpoint of your specification. So you specify report URI as example.com CSP violations, and it'll send some JSON information to you that'll help you identify the things that are breaking on your website or the things that would break based upon this policy. So this gives you a deployment mechanism that's relatively straightforward. You deploy a policy as report only. You look at the reports that are coming in, you fix bugs on your website that are causing these reports, or you tweak the policy because perhaps there was a section of your website that you didn't actually look at. Once you have a policy in place that's not generating a large number of violation reports, you can deploy that policy as an active policy. What's nice is that you can actually have an active policy and a reporting policy existing at the same time. So you can have a very loose policy like this one, which simply says only load resource over HTTPS. That is, no mixed content of any sort. I'm serving my site over HTTPS. I don't want to load any information over HTTP. Default source of HTTPS will allow you to do that. It simply says no source that isn't HTTPS should be allowed to deliver content. This is a relatively loose policy because it says any host that's on HTTPS. So HTTPS evil.com would also match, but at least it's secure, right? So that's good. What's nice here is that you can deploy this sort of loose policy, and the loose policy is more or less guaranteed to work on your site. And you can test a policy at the same time by setting a report-only flag. So you can have both headers active at the same time. The CSP report looks like this. As you see, it gives you the URL that caused problems. It tells you what resource tried to load. It tells you the policy that was active and which directive was violated. So it gives you some information that allows you to debug the problems that you'll see when you start deploying CSP to your website. You can, of course, also use a report in an active policy. So if you deploy a CSP or a content security policy to your site, you want to know if people are attacking your website. And this allows you to send reports based on violations. So once you're sure that all the code that you deliver matches the policy, you can start getting reports about attacks that are existing against your site. And this will give you information to help figure out where those attacks are coming from, which can be quite useful. There's a good article. This is really just scratching the surface of content security policy. If you're interested, and I really hope you are, because this is the most important thing that's happened in web security, I think, for the last 2 or 3 years. Content security policy on HTML5 Rocks. You should go to HTML5 Rocks anyway, by the way. It's a great website that gives you a lot of information about HTML5 and new features that are coming out. There's specifically an article about content security policy that I happen to think is relatively well written. And it gives you some good information about how you can start using content security policy, what the purpose is, how it works, and how you can deploy it on your websites. I think this is really important. And I think it's not easy to deploy this on existing applications, but there is really no reason at all that you can't deploy it on new applications that you're building. So anytime you start building an application, think about the resources that you're using, and think about the ways in which you can restrict the browser from loading resources that you don't want the browser to load. Content security policy 1.1 is in editor's draft right now. I'm working with a standards body on this, so if you guys have questions at all afterwards, or if you have suggestions about things that you think could be added to a policy like this, please do let me know. There's the working group is the Web Application Security Working Group. If you have any questions at all, you can join public-webappsec at w3.org and participate in all the discussions. So this is a place that's still rapidly in development, so if you have suggestions, we'd be very interested in hearing about them. So that's content security policy. I think it's incredibly important. It's a really good way to reduce the privileges of a website down to the level that you actually need in order to do your job. Another mechanism that HTML5 is starting to provide that does more or less the same thing, or gives you many of the same ideas, is called sandboxing. Sandboxing allows you to include an iframe on your website in such a way that it runs with reduced privileges. Again, if we think about the single origin, or the same origin model, we have example.com and mybank.com. If example.com frames mybank.com, so it loads my bank in a frame, then it doesn't actually have any access to that frame. It can't via JavaScript reach into the frame, and the bank can't reach out of the frame into the parent in order to do any sort of damage. This is a good thing, and it allows you to include untrusted content on your website in a way that can't interfere with your website. So the iframe in and of itself can act kind of like a sandbox. But if you include same origin content, that is, if example.com includes a page from example.com in a frame, for example, a comment or something along these lines, then because they exist in the same origin, the parent can reach down into the child, and the child can reach up into the parent. Both of these might be useful, but generally speaking, they're not. Generally, if you're including content in an iframe, you want it to be in some way separate from the page that it exists within. Sandboxing is sandbox is an attribute that you can apply to an iframe that does exactly this. It works very similarly to browsers that you see these days, where you have a browser. Oh, I'll talk about this in a moment, actually. The attribute is quite straightforward. If you apply a sandbox attribute to an iframe, then a couple of things happen immediately. First, no plugins can be loaded within this iframe. No script can be loaded. Forms cannot be submitted. Top-level navigation simply won't work. That is, if I apply target blank or target top to a link within an iframe, usually that'll navigate my entire page, the window as opposed to the frame. Sandboxing blocks this. No pop-up, so window.open, modal dialogues, things along these lines, can't be created from within the context of a sandboxed iframe. No autoplay, so if I have a video within this link, autoplay won't work. No pointer lock, and no seamless iframes. What's really important, and what I failed to write here, is that sandboxing actually will push the frame into a completely separate origin, regardless of from where it was loaded. That is, if I load a page from example.com in a frame, it won't act as though it's example.com, or it won't act as though that's its origin. It will instead have what's called a unique origin. And a unique origin is one that matches no other origin ever. That is, it has no access to any data from any origin at all. This can be quite useful because it gives you the ability to load untrusted content in a way that simply can't do any damage at all to your website. If script can't execute in the context, then it doesn't matter if someone can maliciously inject script, because it simply won't execute. They won't be able to navigate your page, they won't be able to create pop-ups, they won't be able to bust out of the frame and move users to an area that they weren't trusted to do. You can, of course, loosen these restrictions, and this would be the minimal sandbox that you can create. There's still no plugins, and there's still no seamless iframes, but everything else can be enabled. What's nice about this is that you can create a sandbox that gives only the minimum level of privilege necessary to a website in order for it to do the work that the website needs to do. This concept allows you to separate the concerns within your application. So you can actually break your application into a variety of pieces. And now we'll come back to the concept of a browser. If you look at how Chrome works, you have a browser process that has all the privileges in the world, all the privileges of a normal application running on your system. It can go out to the web and get information. It can go to your disk and get information, or write information to random files on your disk. It can execute arbitrary code, and so on. It's an application with all the privilege in the world. But it's a very thin application. It doesn't do much. Instead, a lot of the work is delegated out to renderer processes. More or less, you can think of every tab as a separate renderer process. The renderer processes ask the browser for information. The browser determines whether or not the renderer should get the information, delivers the information to the renderer, allows it to do its work, and awaits a response. The renderer grabs HTML, untrusted content from the web, does a lot of processing on it in order to build a render tree, and then sends that tree back up to the browser once it's verified that it's trusted. What this means is that the renderer doesn't actually need any of these privileges. It doesn't need to go out to the web. The browser does that for it. It doesn't need to write things to the disk. Again, that's what the browser is there for. So you separate the privileges of your web app, or you take the application, you break it into pieces, and give each piece only those privileges that are actually necessary in order for it to do its job. This allows you to build applications in such a way that each component can live inside of a sandboxed iframe. So what you would basically end up doing is creating an API for your own application based on messaging. So it would be an asynchronous API by which you pass messages into a sandbox, allow that sandbox to do some sort of interesting work based upon the message that you passed in. and then ask the sandbox to send information back up to the parent in order to delegate that work to another process or to do some sort of rendering out to a website. This could look something like this. So here's a toy example of how this might work. We have a content security policy associated with this page that says script source of self. So only script that's loaded from my current origin can be executed within the context of this page, of this protected resource. We load a script called main.js, and we have an iframe on the page that loads sandbox.html. The sandbox allows scripts, but allows nothing else. Main.js looks something like this, and we'll talk about it in a little bit more detail later on. But the idea is simply that we bind an event handler to the button. When I click on the button, we pass a message into the iframe, and we listen for a response. So we listen for messages on the page, and we pass messages into the iframe. It's just a very, very simple messaging API using iframe.contentWindow.postMessage. So we grab the iframe, we grab its content, and then we post a message to that. The iframe looks something like this. The iframe loads in Handlebars, which is a templating library. And it's a templating library that does a couple of things for performance reasons that are a little bit dangerous. Specifically, it uses eval in order to generate a function and executes this function in order to actually do the work of templating. So it takes untrusted code, it evaluates it in some sort of context, and creates a function which can then be executed. This is a bit dangerous, and content security policy of self will actually block you from doing this. It'll block you from using untrusted content in the context of an eval. It'll block eval entirely, in fact. This means that Handlebars could not execute inside the context of the page. So if I look at index.html, content security policy will actually block Handlebars from executing. However, inside the context of the sandbox, there is no content security policy because I haven't set one. It's a completely separate HTML document. It's also a document that doesn't have access to any of the information that was in the main page, that was in index.html. So I can, more or less without issue, allow JavaScript to execute in this context and allow potentially dangerous JavaScript to execute in this context without worrying about it stealing my information, because there's no information in this context for it to steal. It listens for events, or listens for message events, grabs the context that was passed in, and uses that context to populate a template. So Handlebars does its work. It uses eval. It uses this dangerous but very performant code in order to do some templating. Then I can pass that HTML back up to my parent frame. And in the parent frame, you'll see that I'm actually using document.body.innerHTML to write this content out to the page. This is incredibly dangerous. You should really never do this inside the context of an application, because innerHTML will execute script. So if I have a script tag that's pushed into a page via innerHTML, that will execute. The reason that I can do it in this context is because the page is protected by content security policy. It says that even if dangerous content has been injected into the page, no script will actually run. The worst that an attacker could do in this case is deface my website by making the sandbox. If they were able to find a vulnerability in the sandbox, the worst that they could do is generate bad HTML. They couldn't generate dangerous HTML that actually executed script and exfiltrated information. This gives you the ability to separate your application into pieces that need special privileges and pieces that don't need those privileges. It allows you to say that the main application is protected by a very strict content security policy, but pieces of the application that wouldn't fit into that policy or that would have issues, maybe it's a legacy application that you have a very hard time rewriting for this piece, for this new style of programming. You put that into a sandbox, you allow it to execute within the context of that sandbox, and you build a very thin messaging API on top of the sandbox and on top of the application itself in order to pass messages back and forth between these two components. You separate out the concerns, and you say that the one piece of the application should be able to execute script, it should be able to execute potentially dangerous script. And the other piece of the application has no need of this information whatsoever. It should only rely upon this new API that you've built. This gives you a really nice way of extracting pieces of your application that don't need privileges, and to reduce those privileges down to the minimal level that they actually need in order to do their job. There's one other thing that a sandbox can potentially be useful for, and this will be available in, we'll say, the near future. It's in Chrome Canary right now, but it's not quite there yet in other browsers. Specifically, I'm talking about the seamless attribute and the source doc attribute. These allow me, first, to create an iframe that seamlessly blends in with the content of my page. One of the things that you see with a normal iframe is that it's a completely separate document. So it has its own style sheets, it has its own JavaScript, and so on. The seamless attribute allows me to create an iframe in my page and allows CSS to flow down into that iframe. So if I have a paragraph in that iframe, it's going to use the paragraph style from my document, not from its own, or it can override them, of course, but the CSS flows down into that document, or into that iframe. The other nice thing is that a seamless iframe shrink wraps itself to the size of the content on the page. So instead of specifying that I have an iframe that's 500 by 500, I can simply say it's a seamless iframe, which means it'll only be as big as the content that's been pushed into that iframe. This is really quite nice. It works with the same origin policy. So if I load content from my origin, then CSS flows down into it. If I load content from a separate origin, CSS won't flow into it, because I can actually use CSS to extract information from that page with some of the new selector attributes that are out. What you also see here is a source doc attribute. This means instead of making an HTTP request out to a server to get information to populate this page, or this iframe, I can populate it simply by adding information to an attribute. This means that all I have to do is correctly escape information for a single context. I can look at the information that a user has given me, for example, for a comment on a web page. I can escape that in such a way that it works within the context of an attribute, which is easier than trying to escape it for any context whatsoever. And that information is then used as the body of this iframe. So instead of making an HTTP request, I can specify the content of the iframe directly within the context of the page itself. For something like comments, this can work quite well, because what I can then do is sandbox this iframe, so that even if I've completely screwed up when escaping the information, I can ensure that no plugins can run, no script can run, and so on. That the content that's actually being delivered into this iframe can be executed in a very safe way. The sandbox attribute is supported in WebKit quite well. It's been in Chrome for quite some time. It's in Safari 6, and it'll be in new WebKit browsers that come out. It's just been supported inside Firefox. So I think Firefox 18 now has support for the sandbox attribute. And it's supported in IE 10. So it's in the new browsers that are coming out, but it has really no downside for old applications. They will be just as insecure as they were before if you're using this sort of attribute. With that, I think I'll ask if anyone has any questions. Before, I would suggest that you go out and read the HTML5 Rocks article. I think content security policy is the most important thing that's happened, again, in web security for quite some time. I think it's really quite important, and I would be thrilled if even one of you started implementing content security policy on your pages. If you have any questions about it at all, please drop me an email. Please contact me on Twitter or on G+. And if you have any questions right now, I'd be really happy to answer them. Do we have like a mic anywhere?
Yes,
oh yeah, it's over there. Great.
So with the content security policy, you said that you cannot have inline JavaScript anymore. What about inline styles?
It's the same story. There is a mechanism by which you can allow inline style if you really need it. So if you have a legacy application and you simply don't have the time to rewrite it, you can allow inline style, but by default, it's if you set a style source, then inline style will also be removed, because it's just as dangerous as inline script.
I agree. Thanks.
Cool. Great. Thank you very much. Oh, there was another question. If you have a question, just come up and ask. The question is, yeah, so the question is, first of all, this looks difficult. So you're talking about sandboxing, correct? Yeah. So building this sort of API is work. And you have to look at your application and determine what the APIs actually are, what the components are, and then build some sort of messaging framework that pushes messages back and forth between various frames. You're entirely correct. It is more difficult than writing an application in the current style, where you just have everything in a big block that all executes in the same context. It is more difficult, and I do think it's the case that frameworks will start to pick up that work. We see Sandbox now being deployed in enough browsers that I think it'll be interesting for frameworks to start building things out in this way. Until now, it's only been available in WebKit, which has made it less attractive for framework developers. But this is something, if you look at Chrome applications or Chrome extensions, this is something that we're starting to force developers to do now. We use it all throughout Chrome. And this is a mechanism of building applications that we think has such good security characteristics that it's worth the effort for us to start asking people to develop in this way. You're entirely correct, it's more difficult. My contention is simply that the benefits outweigh the difficulty. It won't be the case for every application. But a good example would be the Office document reader inside of Chrome OS. So the Office document reader takes untrusted documents in doc format, parses them with JavaScript, and then renders them to the page. And it does it in exactly this style, where you have a sandboxed renderer that takes information, so you pass a document into that renderer. It does its work. It uses all this untrusted code, or it evaluates untrusted code, and then passes information back to its parent in a way that doesn't create new security vulnerabilities. So it is difficult. It's not the easiest thing in the world, and I don't think I would ever claim that it is. My claim is simply that the difficulty is worth it because it gives you such good security characteristics. You know this piece of your application, even if it's compromised, even if you've made huge mistakes, can't access the information that is secure inside the context of the non-sandbox piece of the application. So it's a difficult problem, I agree with you, but it's one that I think is worth addressing. All right, thank you very much for your time. If you have any questions, I'll probably be at the Google booth downstairs for a lot of time. Actually, one more thing. There's a talk in this room at, I think 4:40, called something along the lines of development with secure HTTP headers. I think it's going to be worthwhile. So if you're interested at all in other things that you can do, other things that you can instruct a browser about in order to make your applications more secure, I'd really suggest that you go to that talk. I think it's being given by Frank Kim, and it should be really interesting. So 4:40, this room, I'll be here, and I hope you guys are too. So thank you very much.